alternating double and single compounds. Bali guys, dalawang compound na to ay pwedeng i-convert sa isa't isa from cycloaliphatic to into aromatic and aromatic into cycloaliphatic compounds. And para magawa yon, gagamit tayo ng dalawang process which is yung dehydrogenation and hydrogenation. Kapag cycloaliphatic, tapos i-convert nyo into aromatic compounds, ang gagamitin nyo ay dehydrogenation. Dehydrogenation guys ay yung pag-remove ng hydrogen atom sa molecule. While kapag aromatic naman to cycloaliphatic compounds, hydrogenation naman yung gagamitin nyo. So si hydrogenation ay removal, si hydrogenation naman ay additional. Kumbaga mag-a-add kayo ng hydrogen atom sa molecules or sa compound. For example, si benzene i-convert nyo into cyclohexane. Di ba ang chemical formula ni benzene ay C6H6 plus mag-add kayo ng hydrogen atom na CH2, magre-result siya sa C6H12 which is yung cyclohexane nga. And dito guys sa diagram na to, presented din yung mga chemicals na pwede ma-produce sa kanila. Including na dito si benzene which is major component siya ng gasoline and other petroleum products. And ginagamit din siya para makapag-produce ng plastic, synthetic rubber, and pesticide. Tapos si toluene naman, major component din siya ng gasoline. And also, ginagamit siya para makapag-produce ng paint, solvents, and explosives. While si silenes naman, ginagamit siya para makapag-produce ng polyester, polyethylene bottles, and paint thinners. And si caprolactam and cyclohexane, ginagamit siya para makapag-produce ng cyclone, which is yung synthetic fiber na ginagamit natin sa tela, sa clothing, carpets. And si phenol ay nakapag-produce ng plastics, resins, and pesticides. And lastly, si bisphenol ay nakapag-produce ng polycarbonate na type ng plastic na ginagamit for food packaging and water bottles. Overall, dito sa schematic diagram na to, pinapakita yung pagka-complex ng chemistry and interconnection ng cycloaliphatic and aromatic compounds sa isa't isa. Next slide po. Aromatic has several stages and may be grouped as first, feedstock, which is yung first generation petrochemicals na natin. Second, intermediate. And third generation petrochemicals is yung finished products. Next slide po. For feedstock, raw hydrocarbons for petrochemicals come from crude oil refining by distillation and catalytic processes. Kasi distillation, di ba, ay separation technique wherein involves heating the mixture para mag-vaporize and mag-condense pabalik into liquid. While si catalytic process naman ay gumagamit ng catalyst para ma-accelerate o mapabilis yung chemical reaction without being consumed in the process. Bale, both of these processes po ay ginagamit sa petrochemical and chemical industries. Next is catalytic reforming and catalytic cracking processes produce essential raw materials such as benzene, toluene, and xylene. Nabanggit ko na naman po kung ano sila at kung saan sila ginagamit. Ano po? Tapos, si petrochemical plants generate these byproducts including heavier aromatics. Guys, kapag sinabing heavier aromatics, mas complex yung kanyang ring structure at yung molecular weight nila ay mas mataas kumpara kina benzene, toluene, at xylene. And lastly, feedstock for petrochemical plants either nanggagaling mismo sa refineries or napuproduce mismo siya within petrochemical facility through further processing. Next slide po.
So for the intermediate stage, thermal cracking of hydrocarbons like ethane, propane, butane, and naphtha is vital step in the production of valuable resources for the petrochemical industry. Cracked gases including ethylene, propylene, and butylene serve as essential monomers for olefin plant, playing an important role in the production of various plastic and polymers. So for the intermediate stage po, gumagamit tayo dito ng thermal cracking na kung saan ito yung process na paglalagay ng crude oil sa high temperature at saka sa high pressure para mag-breakdown yung hydrocarbons para makapag-produce siya ng naphtha, gas, gas oil, and at coke. Next slide po.
And for finished products, petrochemical intermediates are essential in the production of a wide range of products including plastics, rubber, fibers, solvents, and paints. Through polymerization process, kinoconvert niya itong mga intermediates na to sa iba't ibang polymers which is essential nga sa production ng plastics, rubbers, and fibers. Bali guys, yung polymerization process ay chemical reaction kung saan yung maliliit na molecules at tinatawag na monomers ay pinag-iisa para makabuo ng chain-like molecules known as polymers. Next, plastics are produced in different forms such as extrudates, granules, powders, and beads at manufacturing units. Itong mga plastic na to ay pwede i-categorize into two types, thermoplastic and thermosetting plastic. Kapag sinabing thermoplastic guys, pwede siyang tunawin at the same time isolidify ng paulit-ulit. And kapag thermosetting plastic naman, nag-undergo siya ng irreversible chemical changes kapag pinainitan or na-expose sa init. Next, synthetic fibers are manufactured from high-modulus elastic polymers, while elastomers or rubbers possess a low modulus of elasticity. Bali guys, yung mga rubbers na to ay ginagamit o ginagawang sheets na minimix sa iba't ibang chemicals, including yung sulfur, para makagawa ng rubber products like yung gulong, sapatos. And then lastly, petrochemical manufacturing processes involve various chemical reactions, often catalytic with associated heat effects such as dissociation. Guys, yung dissociation ay chemical process in which the compounds break down into its constituent part or ions kapag na-expose sa init, electricity, or sa solvent. Tapos dehydrogenation and hydrogenation, nabanggit ko na naman siya kanina, na yung pag-remove at pag-add ng hydrogen atom sa molecule. And then polymerization and condensation. All of these are chemical reactions na essential sa petrochemical industry, pharmaceuticals, material science, and food processing industry. Next slide po.
So, sa types of polymerization reaction. So, pag sinabi po natin polymerization is a chemical process. Ito yung pagsasama ng parehas at magkaibang monomer para po makabuo ng polymer. And it most usually occurs with the presence of catalyst. So, ang una po nating types is addition polymerization. So, it involves a chain reaction in which monomer join in a chain. Ang type ng polymerization na ito ay yung pagkasama ng dalawang monomer para makabuo ng long chain of polymer. So, next is condensation polymerization. So, it involves, next slide po. Condensation polymerization. Sa condensation polymerization po, involves two monomer with same or different which combine to form a polymer with elimination of small molecular weight by product like water. Sa type naman ng polymerization na to, ay kagaya lang nung nauna, na nagsasama ang monomer para makabuo ng polymer. Ngunit, inaalis nito ang mga other molecular material like water at saka HCl. And that's all for aromatics. Thank you. The next presenter will be Mr. Christian Lonoy, and he will be discussing the naphtha cracking.
Hello. So, ayun yung 5 stages sa petrochemical plant. Ang una ay ulitin ko, feedstock preparation, which is your crude oil or natural gas. Then, steam cracking, kung saan yung iyong feedstock ay undergo steam cracking, which heated in the presence of steam to break down large molecules into smaller ones. Ang next ay olefin production. After steam cracking, the resulting Olefin-rich stream undergoes further separation and purification processes to obtain pure ethylene, propylene, and other olefins. Next is polymerization, um, which is polymerized to create various polymers such as polyethylene, polypropylene, which are used in a wide range of product. And last is aromatics production. Aromatics like benzene, toluene, and xylene are often produced from the hydrocarbons, primarily in processes like catalytic reforming and aromatics extraction. So, yun yung mga stages sa petrochemical plant. Okay, next, naphtha cracking.
Hello po, i-discuss ko naman po ang naphtha cracking. Next slide po. Yan, what is naphtha? Ano nga po pa pala ang naphtha? Ang naphtha is a mixture of hydrocarbons boiling in the range of the lowest boiling component, C5 to 150 degrees Celsius. Included po dito ay pa-next po. Paraffins, ito po ay straight hydrocarbon chains na which is single bonded. Next po, included din ang naphthenes, which is cyclic hydrocarbons, or kung tawagin natin ay cycloalkanes. Tapos next po ulit, included din dito ang aromatics, which are planar ring systems with alternating single and double bonds. Next po. It is found that paraffins yield olefins when heated at a high temperature. Paraffin daw po kapag hinit in high temperature ay mag-produce ng olefin. Next po. On the other hand, naphthenes and aromatic hydrocarbons become heavier or decompose to carbon when also heated at a high temperature. Yung next po. So, as we can see po, ito po ang ating naphtha cracking system. Naphtha cracking is carried out in a tube steel furnace at a temperature above 800 degrees Celsius. Light hydrocarbons obtained from the initial cracking reactors further crack into lighter olefins and propagate until the reaction temperature is brought down or quenched. If the reaction continues indefinitely, branched and cyclized heavy hydrocarbons will be produced and coke will be generated as the ultimate product. Para mapigilan po ang pagkakaroon ng coke, ang naphtha feed ay pinapadaan sa heater tube at a very high speed. Products from the cracking furnace, yun pong kulay gray po na may parang bahay na may chimney sa taas. Yun po yung cracking furnace are quenched by hot oil and cooled before they are sent to the separation units. The product mixture then flows through a series of separators. Included po dito ang demethanizer, which liquefied gases are separated from methane. Sa ethanizer, it separates ethane and ethylene mixture from liquefied gases containing propane, propylene, butane, butylenes, and etc. Pati po sa drip propanizer, liquefied gas mixtures from propane and propylene. And the butanizer, butane, butanes, and butadiene are recovered as the top product and heavier are recovered as the pyrolysis, gasoline, or the bottom product. Lahat po yan ay multiplated distillation columns. Ang byproducts po ng naphtha cracking ay propylene, butylene, butadiene, and aromatics such as benzene, toluene, xylene, isomeric paraffins, naphthenic components, and polynocular aromatics. That's all po sa naphtha cracking.
For the primary fractionator or
Wait,
stabilizer,
asan yan si Dayan? Dayan, pabalik ako ng... Wait lang yan. So, tulad nung sinabi kanina, sinapta ang ating feedstock. Sinapta ay nagre-range ng C5 to C9. 'Di ba? Ayun yung sabi sa crude distillation unit o CDU. Then, papasok siya dito sa steam cracking or pyrolysis natin. Ito yung cracking furnace natin na mag inject ng steam para yung mga large molecules natin na mga large carbon molecules natin ay mag-breakdown into small pieces. Tapos, pasok dito sa column na 'to, sa stabilizer natin na ito, si C1 to C9. Bakit nagkaroon ka na ng C1? Kasi nga nag-undergo siya ng pyrolysis, yung thermal or heating heating process. So, nagkaroon ka na ng maliliit na carbon chain. So, yung fuel oil mo ay dito sa bottom part, which is C7 to C9. Then, yung C1 to C6 ay dito pupunta sa upper part and cooler, then compressor, then pasok dito sa separator na to. Um, ang papasok sa separator nito, sa bottom part, ang lalabas ay C4 to C6. C4 to C6. Then, itong pyrolysis gasoline, sa bottom part, which is your C5 to C6. Then, ang C4 mo, dito lalabas siya sa upper part, the debutanizer. Then, pupunta siya dun sa butylene separator mo kung saan ang butane is sa bottom part and butenes is sa upper part. Back tayo dito sa separator mo dito. Then, punta siya dito sa absorber or cascade cooling. Siyempre, galing ka sa surface sa cracking furnace na to, nag-inject ka ng steam. So, magkakaroon ka ng reforming process from sulfur na kung saan yung sulfur mo ay present na dahil ng steam na nangyari dito. Then, nag-inject ka ng steam magkakaroon ka na ng acid. So, yung mga acid na yun ay isa-separate mo to kasi yun yung mga impurities mo yung SO2, H2S, CO2, um, carbon monoxide or CO. Yan yung mga impurities na isa-separate mo. And yun yung sa bottom part ng absorber mapupunta. And sa upper part ay yung H2 purification ay sasalain din. Then ang lalabas na lang dito from H2 sa purification, ang lalabas na lang dyan ay C1 to C3. Then si demethanizer, dadaan kay demethanizer, labas si C1, which is your methane or CH4 to fuel gas. Then demethanizer, labas ay C2 to C3. Pasok kay deethanizer, um, labas sa bottom part ay si C3, sa upper part ay si C2. Then pasok kay ethylene separator kasi meron ka na dining um, C2. Then sa C2 kay ethylene separator, bottom part is si ethane recycle. Then sa upper part is ethylene. Yun yung kailangan nating end product para kay polyethylene plant. Then dito naman balik tayo kay depropanizer kung saan yung C3 na lang yun na pumasok. Then sa depropanizer pasok kay propylene separator kung saan sina-separate si propane at saka si propylene. So end product natin dito ay ethylene, propylene, butenes at saka methane. So yun. So tuloy na.
And po, for the primary fractionator or stabilizer po, ang nakalagay, next slide po. Next slide po. Yan. Thank you po. Ayun nga po, sinasabi po diyan na yung mga crack liquids and gases po ay pinaghihiwalay sa isang fractionating column na ang ilalim na produkto ay may mga mabigbigat or mga crack na langis na mayaman o mataas sa mataas sa boiling aromatics po. Tapos yung mga yung heavy oil na yon ay bahagyang ginagamit bilang quenching medium for the products from the furnace, and ito po ay bahagyang ibinebenta bilang carbon black feedstock dahil sa mabibigat at mga nilalaman po nito ng mga aromatics. At yung mga crack gas po na yon ay naglalaman ng mga hydrocarbons. Parehong meron po siyang saturated and unsaturated mula sa methane hanggang C7 hydrocarbons, at ito po ay lumalabas mula sa taas ng column, na pagkatapos ay pinagko-compress at hinuhugasan po nun sa amin upang alisin yung mga hydrogen sulfide at carbon dioxide ng mga gas. Sa kabilang banda naman po, yung sinasabi po nilang primary fractionator or stabilizer po ay pinagkakamalan din po siyang distillation column. Pero po, sa tunay po na buhay po ay may difference po between stabilizer column at distillation column po. So, dun sa distillation, it is a term that encompasses a variety of separation techniques where a system of two or more components ay hiniheat within a separation device, katulad po ng flash drum or distillation column. At yung the vapor generated is condensed back into a liquid na mayaman po siya sa higher composition of na may lighter component and lower composition, at may less volatile at mabibigat po na component din po siya. While the stabilizer po or tinatawag po nilang stripping ay yun po, typical po siya na nag-a-attempt to remove the light components from a heavy stream, or essentially stripper is a distillation column that strips light material out of it by applying heat and sometimes returning the cool distillate into the column to the further purify the bottoms product, removing more incremental light material from the bottoms. But stripping or stabilizer and distillation are pareho po sila ng method of separation of components, pero magkakaiba sila in their relative volatility or tendency to become a vapor as temperature rises. From a simple semantic point of view, stripping is a form of specialized distillation. Next slide po. For the hydrogen separator naman po, wait lang po. Yun po. Sa hydrogen separator naman po, ito po ay various process based on a phase change, which are absorption, adsorption, permeation through membranes, and chemical reactions are available for separation po. Pwede din po siya sa recovery and purification of hydrogen. Pero some of those processes po are employed in practical operations according to operating conditions, specification, at sa mga use po for removing and recovered components. So yung prime technology po is the pressure swing adsorption process, which have several advantages over the other methods. For the simple explanation po, which is hydrogen, alam naman po natin na ang hydrogen is isa sa mga important commodity sa industrial fields po, such as ammonium production, petroleum processing, chemical and petrochemical industries, even the metallurgical processing and electronic industry. Pwede din po siya sa mga town gas and aerospace industry. At normal po siya manufactured by removing other components or recovering into from gaseous mixtures generated into various chemical processes po. when we say the crude hydrogen-based gases produced from hydrocarbons, ito po ay ginagamitan po ng steam reforming or partial oxidation na nagko-contain ng various co-products or byproducts and residual reactants such as carbon dioxide, water vapor, carbon monoxide, and methane. For the term of separation naman po, is a generally used for all first stage operation to increase hydrogen concentration. Whereas the term purification is used for secondary operation to upgrade product hydrogen. For various processes to separate and purify hydrogen are available. Meron din po sila mga physical and chemical principles and ito po ay kinaklassified into for example, yung phase change, absorption, permeation through membranes, and chemical reactions. Some of those processes are employed in practical operations. Among them, the prime separation technology is pressure swing adsorption or yung tinatawag po natin na PSA process, which has several advantages over the other methods and widely used in sa iba't ibang field of hydrogen separation. Wait lang po. Tapos, ayun nga po, ginagamit po siya sa iba't ibang field ng hydrogen separation at meron din naman po mga other methods na available for pre-treatment of crude hydrogen or final purification which is mas mataas po yung mga purified level po nila. Tapos, in addition to performance improvement of conventional separation, based on the phase change po, yung adsorption and absorption technical progress is being made on new ones using palladium membranes or ginagamitan din po sila ng polymer membranes or metal hybrids. Hydrides rather. Yun nga po, madami din pong sangay po yung hydrogen separator which are the separation and purification of hydrogen, partial condensation, absorption methods, and adsorption methods. Yun nga, for the final explanation po, yung hydrogen at yung mga mixtures po nila ay kailangan po i-handled and used on a large or small scale because there are three forms of compressed gas which are the cryogenic liquid or methyl hydride involves hazard resulting from its physical and chemical properties and combustion characteristics. And however, yung mga fine particles po produced during repetitive cycles of hydrogen absorption and desorption are often for pyrotropic and may induce an internal stress that causes rupture of the container. Yun lang po. Thank you po.
So, one of hydrogen separators is the demethanizer. Ang demethanizer or demethanizer column ay isang specialized equipment na ginagamit sa natural gas processing at sa mga petrochemical industries. From the word itself, ang primary function nito ay ang i-separate ang methane from mixture of hydrocarbons including ethane, propane, butane, and other heavier hydrocarbons. The demethanizer column is a tall vertical vessel designed to perform fractional distillation and separate these hydrocarbons based on their different boiling points and other molecular weights. Next slide po. Here's an overview of the demethanizer column keys and key components in its operation. According to the column structure, the demethanizer column consists of a vertical cylindrical vessel with various internal design to facilitate the separation process. It also has feedstock inlet, means that the mixed hydrocarbon feedstock, often derived from natural gas wells or other hydrocarbon sources, is introduced at the bottom of the column. Another component is the heat exchange. This preheating helps improve the efficiency of the demethanizer. Then the vaporized ethane and lighter components rise to the top section and are collected as the product through the vapor outlet. The remaining liquid, which is enriched in heavier hydrocarbons, is collected at the bottom section and can be further processed or sent for downstream applications. The demethanizer column is a critical unit in natural gas processing, ensuring the efficient separation of methane for use as a clean fuel while also recovering other valuable hydrocarbons for various industrial applications. Its design and operation are optimized to achieve the desired level of separation and product purity. Next slide po. The ethanizer. The ethanizer is a pressure vessel designed to separate ethane from hydrocarbon-rich natural gas in the oil and gas industry. It is usually connected to the propanizer and the butanizer vessel. Sa deethanizer naman, the term deethanizer refers to a unit or process used in the field of petrochemical or natural gas processing. So kung kanina yung demethanizer ay para ma-separate ang methane sa mga heavier hydrocarbons, ang deethanizer specifically, part naman ng distillation or fractionation system na ginagamit naman para ma-separate ang ethane from the mixture of hydrocarbons. Next slide po. So as you can see in the screen is the deethanizer column unit. In a typical deethanizer column or unit, a mixture of hydrocarbons is heated and then introduced into a column where it is separated into different components based on their boiling points. Since ethane has a lower boiling point than many other hydrocarbons, it will vaporize and rise to the top of the column, where it can be collected and further processed or used for various industrial applications. In this simplified schematic, the deethanizer column is a tall, vertical vessel divided into sections, the top section and the bottom section. Next is the feedstock, which contains various hydrocarbons including ethane, enters from the bottom section. It also had heat exchangers, expansion valves, and other equipment for temperature and pressure control. Then fractionation trays or structured packing material are represented inside the column to enhance vapor liquid and contact in the separation process. The vaporized ethane and lighter components rise to the top and are collected as the product through the vapor outlet. Then the remaining liquid, which is enriched in heavier hydrocarbons, is collected at the bottom section and can be further processed or sent for downstream applications. So, the ethanizer ay isang important component sa production ng various petrochemical products and natural gas processing because it allows for the separation and recovery of ethane, which can have different uses and market values compared to other hydrocarbons in the mixture. Yun lang po.
For the ethylene separator and depropanizer. Ethane is a gaseous hydrocarbon with the chemical formula C2H6. It belongs to the paraffin series and is simplest hydrocarbon that has a single bond between two carbon atoms. Ethane is a colorless and odorless and is found in natural gas, petroleum, and coal. Ethane is mainly used as a feedstock for ethylene production in petrochemical industry. And for the ethylene is a flammable colorless gas with a sweet and musky odor. It has the chemical formula C2H4 and is a simplest alkaline containing a hydrocarbon containing a carbon-carbon double bond. Ethylene is a produced from natural gas and the petroleum and used to as a monomer for making polyethylene ay widely used as a plastic. For ethane-ethylene separator, ang ginagamit dito ay yung wait lang, yung de-ethanizer para ma-separate yung ethane and ethylene. A C2 mixture from the top of the de-ethanizer column is passes through the another distillation column that separates ethylene to the top and the ethane to the bottom. Ethylene is a center storage to use up in the polyethylene synthesis plant. Ethane is this column is recycled to a small cracking furnace to yield a additional ethylene. And for the depropanizer is a type of distillation column that used to separate propane from the mixture of hydrocarbons, such as a butane and pentene. So operates a high pressure and temperature uses for the boiler to provide heat to the bottom of the column. The propane leaps to the top of the column as a vapor while the heavier components leap to the bottom as a liquid. Kung makikita nyo dito sa aming picture ay parang example niyan ay yung pagre-refine ng crude oil kung saan yung pinakamabigat na vapor nasa baba and for the mababang yung pinakamagaan na vapor ay nasa taas.
So, yun, good afternoon po sa lahat. Ako po si Michael Perez at ang naibigay po sa aking topic ay ang propane, propylene separator, and the butanizer. So, bago tayo pumunta sa separator, atin muna alamin kung ano ang pinagkaiba ng propane sa propylene. Next slide, please. So yun, pag sinabi nating propane, meron siyang molecular formula na C3H8. Makikita natin sa slide na meron siyang tatlong carbon at 8 na hydrogen. At it is a 3-carbon alkane. And also, it is a part of family of liquefied petroleum gases or the LPG, which also includes butane. Physical properties naman po niya, yung sa color po, colorless po, tapos sa odorless gas at normal temperature and pressure. Next slide po. Pag naman po sinabi nating propylene, siya po also known as propene, is a hydrocarbon which the molecular formula of C3H6 na may yun nga, tatlo na carbon at 6 na hydrogen. It is unsaturated alkene. Ano ba pag sinabi natin unsaturated alkene? Type siya ng hydrocarbon na nagko-contain na a carbon-to-carbon double bond. Tapos po, ang propylene po ay isang key building block in the petrochemical industry. It serves po siya ng primary raw mats in the manufacturing of various chemicals and products po. And also, it is widely used in various applications due to its versatile chemical properties. Next po. So, bago nga tayo dumako sa separator, bakit natin kailangang i-separate ang propane to propylene? Meron akong tatlo dito. First is different application and uses. Nasabi ko to dahil ang propane ay primarily used po as fuel for heating, cooking, hot water, and various industrial application. Pag naman po sa propylene, propylene is a critical feedstock in the petrochemical industry at ginagamit po siya sa manufacture polypropylene. Yan po. Sa second naman po ay yung sa chemical composition and properties. Ang propylene and propane have different molecular structure due to the presence of a double bond in propylene. And third po is the efficient production utilization. Efficient separation allows for optimized production processes by separating propane and propylene. Industries can tailor the processing conditions for each compound, ensuring maximum efficiency and yield in their respective application. Next po. So, doon na po tayo sa propane-propylene separator. A propane-propylene separator is a specialized piece of equipment designed to separate a mixture of propane and propylene, which are both hydrocarbon gases with different properties and uses. Here's how a propane-propylene separator might work. Ayun nga, first the introduction ng ating mixture. The mixture containing, yun nga, magkahalo pa sila eh. Contain pa ng propane at propylene. Tapos next na po yung separation process. The separator uses various physical or chemical properties of propane and propylene to separate them effectively. Common methods po nito ay yung distillation. Ang distillation po, yun nga po nasa third. One of the most common methods po involved, which exploits the difference in boiling points between propane and propylene. Propane has a lower boiling point than propylene. So heating the mixture allows propane to vaporize and be collected separately from propylene. Fourth po, for the collection of propane and propylene. Propane with its lower boiling point vaporized first and is collected. Propylene with its higher boiling point remains in the liquid state and can be collected separately. Ang pang-fifth naman po yung quality control, yun nga yung na-separate na propane sa propylene are typically subjected to quality control measure to ensure they meet the required purity standard. Next po. Ayun, sa debutanizer. Makikita po natin sa figure nito, ito po isang debutanizer tower. Yun po na the butanizer is vital component in the refining and petrochemical industry, enabling efficient separation and purification of hydrocarbons na to produce high quality products, improve process efficiency, enhance safety, and optimize economic returns. A debutanizer is a certain type of fractional distillation column. It is used to separate butane from gas during the refining process. In order to separate or purify the liquid, distillation is used as a process of heating a liquid to vapor and condensing the vapors back to liquid. Yun lang po. Thank you po sa inyo.
So for conversion processes for selective petrochemicals, next slide po. So, the first one is the polyethylene. So it has a chemical formula of C2H4. It is light, versatile synthetic resin made from the polymerization of ethylene. It is known to be a highly ductile, known for possess very high impact strength. Most important application of polyethylene is in packaging plastic products. This plastic is often employed for the production of plastic bags, plastic films, bottles, geomembranes, and containers. So polyethylene is the one of the most widely used and versatile plastic in the world today. So it is a thermoplastic polymer made from ethylene monomers. It is classified into various types based on its density and branching, including low-density polyethylene and high-density polyethylene. So, yung low-density polyethylene is known for its flexibility and ginagamit siya most common in plastic bags. While yung high-density polyethylene, ginagamit siya in bottles, pipes, and containers. So polyethylene exhibits excellent chemical resistance, making it suitable for a wide range of application. Meron siyang low melting point, making it easy to process through various methods like extrusion and injection molding. So, ang polyethylene then is a lightweight and has good electrical insulating properties, and it is known for its durability and resistance to moisture and chemicals. Next po. So yung next one is the polyvinyl chloride, high-strength thermoplastic material used in various industries like building, electronics, electrical, automotive, medical, and packaging. It is an excellent material for insulation due to its high dielectric strength and vapor barrier capacity. It is lightweight, durable, low cost, and easy processability. So, polyvinyl chloride, or also known as PVC, is a versatile and widely used plastic polymer with a range of application in various industries. So, PVC is a synthetic polymer made for vinyl chloride monomers. Um, Siya yung one of the most produced plastic globally. Um, PVC is known for its durability, flexibility, and cost effectiveness. So, PVC used commonly in construction industry for pipes, fittings, and siding. Also, ginagamit din siya in the medical devices like IV bags and tubing due to its non-reactive nature. PVC is used in automotive interiors, clothing, and inflatable structure. Yun lang po. Thank you.
Hello everyone, good afternoon po. Pakibalik po sa polystyrene. So this passage po is talking about different ways to turn styrene, which is a type of chemical, into a material called polystyrene. So there are four methods po: the mass, solution, emulsion, and suspension polymerization. So in the mass polymerization method, styrene is heated up in a controlled environment, which is between 80 degrees Celsius to 85 degrees Celsius, in a special container or the batch reactor with nitrogen gas. This process has a relatively slow con- conversion rate of 30% to 40% and takes a long time, around 40 to 50 hours. So it is mainly used for smaller production setups. One special thing about this method is that it doesn't use any catalyst or initiator chemicals. Because of this, the resulting polystyrene is a well suited for use in electrical insulations, meaning it can be used to keep electrical components separate and protected. So for solution polymerization method, so this is a technique used to create polymers which are long chains of molecules linked together. In this case, it's being used to make polystyrene from a chemical called styrene. So during mixing styrene and solvent, styrene serves as the raw material and a liquid called a solvent are combined in a stir tank blender. The solvent helps dissolve the styrene, creating a uniform mixture. During the series of reactors, the mixture is then pumped through a series of reactors. So reactors are special vessels where chemical reactions occur. In this context, they are used to trigger the polymerization process. In heating facilities, each of these reactors is equipped with it. This means they have the capability to increase the temperature inside the reactor. This is important because raising the temperature can speed up the chemical reactions needed for polymerization. So, during batch suspension polymerization, this process involves dispersing small drops of styrene, or the main chemical, into the water. This is done in the presence of a substance called benzoyl peroxide, which kickstarts the chemical reactions needed for polymerization. In emulsion polymerization method, this method uses a stir tank autoclave, which is a special container that can handle high pressures and temperatures. So inside this container, styrene and water are mixed together and emulsified. This means they are combined in such a way that they form a stable mixture even though they don't naturally mix well. An initiator is added to start the polymerization. During product separation, after the polymerization process, the resulting product is separated from any styrene molecules that didn't react. These unreacted molecules are called monomers. The separated monomers can then be recycled, which is a suitable practice. So in addition, polystyrene is a type of plastic that's lightweight, rigid, and commonly used in things like cups, packaging, and insulation. It's often referred to as styrofoam when it is in the form of those white, foam-like materials you might see in packaging or disposable containers. Next slide po. Polybutadiene. So, It this is a process involving butadiene, which is a type of chemical. So, butadiene is a chemical obtained as a byproduct from a process known as NCU, which stands for neoprene chain unit. During polymerization, the butadiene is then subjected to a process called catalytic Ziegler-Natta polymerization. This process transforms the butadiene into a product that is similar in nature to a natural rubber. A solvent is employed during this reaction to maintain the catalyst, or serves as a substance that speeds up the reaction, and the butadiene in a solution. This ensures that they are well mixed and the reaction proceeds smoothly. The separation of product and unconverted monomer is formed after the reaction, so it is separated from any butadiene that didn't undergo the transformation. This unconverted butadiene is collected and reused, minimizing waste. So the solvent that was used to keep the reaction going is then processed. It's first evaporated to remove any impurities or leftovers chemicals. The purified solvent is then reused in the subsequent reactions. For the final drying step, the polymer produced from the process needs to be dried to remove any remaining traces of solvent. This results in the final product, which can be used for various applications. So polybutadiene is a type of synthetic rubber. It's made from polymerization joining together of smaller units of a chemical called butadiene. This creates a material that has excellent elasticity, making it very stretchable and flexible. Polybutadiene is used in various applications like tires, shoe soles, conveyor belts, and even some industrial coatings. It's valued for its durability and resistance to wear and tear. That's all po. Thank you.
Next po. So, styrene butadiene rubber. So, styrene is a colorless liquid derived from petroleum and is used as one of the monomers. It provides hardness and heat resistance to the final styrene butadiene rubber. While butadiene is a colorless gas also obtained from petroleum. It imparts flexibility and elasticity to the butadiene rubber. So, styrene can be copolymerized with butadiene to yield styrene butadiene rubber, or also known as SBR. So, polymerization is carried out in a stirred tank reactor at around 50 degrees Celsius in the presence of free radical initiators like potassium sulfate in an ammoniacal. So, si SBR po, siya po ay mixture ng approximately 75% po ng butadiene and 25% naman po ni styrene. Next slide po. So, yan po yung chemical ano po ni styrene butadiene and chemical structure po. Then, so si SBR po si styrene butadiene rubber po is ginagamit po mostly sa mga automobile and truck tires. Ito po ay ginagamit as an replacement po for natural rubber. Si SBR din po ay ginagamit po for producing footwear, conveyor belts, and various other products due to its excellent balance of properties including wear resistance, abrasion, resistance, and flexibility. Next po. So, nylons. Polymers of amine or polyamides are excellent for making fibers. These are well known as nylons. Nylons are among the most widely used synthetic fibers. For example, they are used in ropes, sails, carpets, clothing, tires, brushes, and parachutes. They also can be molded into blocks for use in electrical equipment, gears, bearings, and valves. So, si nylon po ay can be drawn, cast, or extruded through spinnerets from a melt or solution to form fibers, filaments, bristles, or sheets to be manufactured into yarn, fabric, and cordage. So, pwede din po siyang ma-form into molded products. So, si nylon po ay mayroong high resistance to wear, heat, and chemicals po. So, next na po.
Hello po, good afternoon. I'm Nina Gabriel Di Plata and i-discuss ko po yung last two ng conversion processes for selected petrochemicals. Phenol formaldehyde, also called as phenolic resin. Ang chemical formula po ng phenol ay C6H5OH and ang formaldehyde ay HCHO. So ito po yung any of a number of synthetic resins made by reacting phenol. So, ang phenol ay yung aromatic alcohol derived from a benzene with yung formaldehyde, a reactive gas derived from methane. So, ang phenol formaldehyde resins were the first completely synthetic polymers to be commercialized. So, yung reaction nito ay carried out sa kettle-type reactor at a temperature of 160 degrees Celsius at atmospheric pressure. So yung reaction time niya is less than 1 hour lang and yung product from the reactor is usually blended with hexamethylene triamine and other fillers to make finished resins na ready for molding processes. Next is yung depending on the ratio of phenol to formaldehyde, a variety of grades of resin may be made. So yung typical mole ratios of formaldehyde sa phenol ay nagre-range from 1.2 to 1.9 moles of formaldehyde per mole ng phenol. And yung catalyst levels naman ay nagre-range from 0.5% to 3%. And this is a thermosetting type resin. So, ang thermosetting type resin ay yung type siya where it become permanently rigid and fixed kapag nainitan or na-cure. Meaning, once na sila'y tumigas, hindi mo na siya mapapalambot or marireapply pa. And they have been widely used for production of molded products, kagaya ng billiard balls, laboratory countertops, and coatings or adhesives. Next po. Next po ay ang silicone. Ang chemical formula po ng polymer of siloxanes ay R3SiO3. It is also called as polysiloxane, which is yung any of a diverse class of fluids, resins, or elastomers based on polymerized siloxanes, substances whose molecules consist of chains made of alternating silicon and oxygen atoms. Bale, the lower the molecular weight, polymers are oil, whereas the higher one are solids. So industrially, ito ay napoproduce by alkylating with an organic halide, CH3Cl or C6H5Cl with elemental silicon sa presence ng catalyst like copper and copper oxide at about 200 degrees Celsius to 300 degrees Celsius at a pressure of 100 to 200 kPa for a long reaction time, about 48 hours. So yung reactor is cylindrical column fitted with a screw-type agitator and a jacket. So yung disilanes at trisilanes na na-produce ay paghihiwalayin and then i-hydrolyze separately, each at a temperature of 30 degrees Celsius to 50 degrees Celsius para mag-yield sa silicone polymers. Then, silicon is obtained from silicon dioxide by reduction reaction with carbon about 1,300 degrees Celsius in an arc furnace. So yung reaction nito ay nag-i-involve ng transfer of electrons between chemicals like atoms, ions, or molecules involved in the reaction. And lastly, their chemical inertness, resistance to weather and oxidation, and stability at both high and low temperatures have led to a wide range of commercial applications from lubricating greases hanggang electrical wire insulations, and biomedical implants kagaya po ng mga breast implants na ginagamit. Yun lang po. Thank you po.
Thank you. Naintindihan niyo? Naintindihan ng petrochemical process, yung mga stages,
po, ma'am.
kung paano ang naphtha cracking process? Naintindihan ha? O1. Ulitin ko yung mga nag-report. Barnacia, De Guzman, Fahanilan, Rivera, Joven, De Luna, Lonoy, Panganiban, Hermidilla, Carrera, Perez, Bisa, Garcia, Generoso, Plata. May nalikdangan ako, may na-miss ako. Lahat nabanggit ko.
Yes po, ma'am.
Pa-upload ako ng PPT nyo dito sa atin para maging reference din ng mga kaklase nyo. Then, yung activity nyo dapat na ipapasa ngayon. Hanggang bukas, matanggap ako hanggang alauna na maipasa siya sa school, ha? Then, yung mga
Sige po.
nag-report, may +7 sa midterms. Thank you kung wala ng concern. Class dismissed na. Ano yan, Dayan?
Ma'am, may PM po ako sa inyo. Thank you po.
APM. Thank you. Ano pa? Oo. Seven.
Ma'am, 17 po.
7.
Kala ko 7.
7 lang. May question pa yung iba? Yung activity ha, bukas. Nasa school ako. Thank you.
Thank you po.
Thank you po.
Thank you.
Thank you po.
All po, ma'am.